hypothesis testing, which you read about this week. And we denote the null hypothesis with an H for hypothesis, subscript 0 for null, meaning that when we say the null hypothesis, it's opposite of what we believe to be true. So, for example, if I believe that I am 26 years old, I'm not, I'm wishing, then my null hypothesis would be that I am not 26 years old. And my alternative hypothesis would be that I am 26 years old. So my alternative hypothesis is what I believe to be true. My null hypothesis is what I believe not to be true. And in statistics, we test our null hypothesis. It can be a little confusing. I had to draw myself pictures to help me with that. And so if that helps you to make a little flashcard, because we're going to be talking about null hypothesis for the rest of the semester. So you want to try and wrap your brain around that. Okay. And so when we test a hypothesis, we always test that, in this case, we say that miles per gallon, and we're saying that the miles per gallon for automobiles, that we can conclude that the new system provides more than 24 miles per gallon. So our null hypothesis here is saying that the new system provides less than or equal to 24, and then our alternative is saying that the new system provides greater than 24. And so this is how we write our hypothesis. Okay. So my first question that I was given says that the Coca-Cola company, per capita, the sales in the United States is 423 8-ounce servings. However, we're curious if the consumption of Coca-Cola is higher in Atlanta, Georgia, which is the location of the Coca-Cola corporate headquarters. So we took a sample of 36 individuals from the Atlanta area, and they were shown to have a sample mean of annual consumption of 460.4 8-ounce servings and a standard deviation of 101.9 ounces. And using an alpha of 0.05, do the sample results support the conclusion that the mean consumption of Coca-Cola is higher in Atlanta? So to get us started on the spreadsheet, I wrote that our null hypothesis is that the consumption will be equal to or less than 423 ounces, and our alternative is going to be that the consumption is going to be equal to or greater than 423. And so we've got these values come from the problem. So our sample, our original sample, was 36 individuals. The sample mean is 460, because that's a sample mean of 460, but our null hypothesis mean was 423 8-ounce servings, and our standard deviation is 101.9. And remember, you're going to have some sort of different numbers there. It might just be that your mean is different or your standard deviation is different, but you're going to have something different. And so to test our sample, I copied and pasted from your text our formula here. So we're going to use the T formula. So our significant level was at 0.05. Okay. So to work our formula, I'll retype all of it so that you can see how I got the numbers. So our T formula equals our population mean minus our null hypothesis mean divided by our standard deviation which is now divided by the square root of n. Close that out, and that is our answer. Okay. So from here, we need to determine our p-value in order to know if we have a significant difference. So degrees of freedom is simply going to be your sample minus 1. So my degrees of freedom are 35. And then to get my p-value, I'm going to run this formula, and let me do it for you again, that I typed out over here. So formula function is t dot dist. And this is a right-sided t-test, and you need to know that if it's right or left. And let me show you how I'll know. Let me plug the values in first. So my x is going to be what am I doing? X is going to be my t, and then my degrees of freedom are 35. I tell it okay, and there's my answer. And the reason that I knew it was a right-sided is because of the symbol right here. This would be a left. So I'm testing right. So you have to know that when you enter in this function. So my p-value is 0.017. And so for it to be significant, I need it to be equal to or less than 0.05. So is it significant? So you'll answer yours, yes or no. In my case, yes, it is. And then you're going to answer this question about rejecting or failing to reject and what you conclude. And I'll leave that for you to do. It says that last year 46% of business owners gave a holiday gift, and a survey showed that this year 45% plan to give a holiday gift. And suppose that we surveyed 60 business owners. So we know that our sample is 60, and that our p is 0.45, and we want to know how many business owners plan to give a gift this year. So we're going to say our n times our p, and so our little n is 27, and that's the answer that would go there. And then it says suppose that they do as they plan, compute the p-value for a hypothesis test that can be used to determine if the proportion of business owners providing holiday gifts has decreased from last year. So our hypothesis is that this year it's less than 0.46. And so to determine our p-value here, we are going to work this formula here that I just copied over from the text, and we have our p, and so we need to determine our PO and our SDP. O and then our SDP. Okay, So our PO is going to be the 0.46, right? And our SDP, we are going to work that formula. Let me go pull that formula for you. It's one we should have committed to memory, but I'm going to copy it over from another spreadsheet. Okay, I copied it over from the book so that we would have it here to reference. So to solve this SDP that I need to determine the equals the square root of P times 1 minus P, the one I said we should have converted to memory. That is not correct. 1 minus P divided by N. And I want to take that, I believe it said to 4 places. Okay, then to solve for Z, I can fill in this equation and say equals my P minus my population P divided by my SDP. And I can reduce that by 1. And there's my answer, negative. And when you have a negative answer, make sure to put the negative in the answer. And then it says using a 0.05 level of confidence, would you conclude the proportion of business owners providing gifts has decreased or increased? And so we need to determine the p-value on this like we did in the previous problem. So did I give? So let's see. So I don't need to use that formula. What I need to do here is to get the p-value, level of significance P, which we want P to be less than 0.05. Then I'm going to do a normal distribution here. Norm S dist. That's what I'm going to do here. So I'm going to insert my formula. There it is. And my Z is, and oops, I didn't mean to do that, sorry. Let me erase that. My Z is here, and my cumulative is true, and so my P is 0.4584. So is that significant at a 0.05? And I will leave these questions for you to answer. And that concludes chapter 6. Good job. See you next week.